Hello, I'm doing the case study on urea cycle disorders. My name is Emily Bro. This is my part 2 of my project for Biochem. Let's get into it. So I wanted to start off with the main case that we had. It's a 6-month-old infant which began to vomit occasionally and ceased to gain weight. He was found to have respiratory alkalosis, and tests indicated a complete lack of activity of that enzyme synthase. I cannot say it, so I will not try. But the overall question was, why does the absence of this enzyme cause respiratory alkalosis? And that's what we're going to try to figure out today. Alright, so first off, we have to start with what is respiratory alkalosis? So it means a low level of carbon dioxide in the blood, and the pH of the blood begins to rise and become more alkane. So the symptoms include dizziness, bloating, feeling lightheaded, numbness, muscle spasms, throwing up, and overall it reduces lung function. And it's caused by breathing heavily. So it would make sense that it has low carbon dioxide in the blood. And so ultimately this can be a very serious problem, and if prolonged, more serious factors can be affected. So we're going to look at the enzyme that I cannot pronounce, and it catalyzes the first step of the urea cycle. And the urea cycle is a process in the body that gets rid of nitrogen from ammonia in the body. It is very critical to the whole cycle itself, because without this beginning one, symptoms would start to take place. Okay, so now what is the urea cycle? Cycle gets rid of ammonia in the body, like we pronounced before, and it's a toxic substance. The body converts ammonia to a less harmful substance, urea, hence the name. Then this gets exported out of the body. And disruptions can happen to the urea cycle because it is inherited. However, there are not too many since it's very well needed in the body. And this makes sense because it's such an important cycle, and if we had a problem, many problems, it will be very clear and we could possibly die. And now, without this cycle, ammonia will stay in the body, changing its pH. And we know that pH is important for balance in the body because the disruption could lead to very serious issues like we saw in the respiratory alkalosis, and if that prolongs, even death is possible. So now we're going to look at ammonia in the bodies, like what it causes and what its effect. Like we said in other slides, it is very toxic in the body, but it's due to its basicity and its charge. And it could lead to alkalosis, which is the study that we're trying to figure out. And it could lead to high problems in the high levels in the blood. And we know that the urea cycle converts ammonia to a lessened compound, and that's what it does in the body. So now we're going to take a closer look at the case study, and we're going to take a look at the smaller instances that happen that kind of will lead you to this problem, the overall arching problem. So the first one we see is that the infant's age is a small giveaway in this case. We know this because most urea cycle disorders present themselves early on because of their ability to be so deadly. In the 6-month-old, in the case, fit the bill. We know that this problem, the urea cycle, is very needed in the body. So it makes sense that it will show itself earlier on because of its need. And if something's not happening, we'll be able to see that very early on because the child would have many problems like we already seen, and it has symptoms, and that just doesn't happen later on in life mostly. And then the second thing that we saw was persistent vomiting in the young infant. This is another symptom that we saw of the cycle disorder and can be as a reason as why the child ceased to maintain or gain weight. If you keep throwing up everything, then you can't get those nutrients and cycles stop working. Not only this cycle, but many other cycles can take effect to this, and it could be a very serious problem. So now, the overall case question was, why does the absence of this enzyme cause respiratory alkalosis? So we know that respiratory alkalosis in this case is due to the lack of the enzyme, which I cannot pronounce again. And this enzyme, as we know, catalyzes is the first step of the urea cycle. We know this. And then when the cycle is disrupted, ammonia is not exported out of the body. It doesn't get rid of it, it stays in the body and causes all these symptoms, like we know. And this excess ammonia leads to change in the blood's pH levels, which is the primary reason for respiratory alkalosis. So we kind of start seeing all of these tied together, and now we want to bring it together. So now, the overall consensus is when the enzyme, which I cannot pronounce, is not available to catalyze the first reaction of the urea cycle, there's a buildup of nitrogen in the blood. This then changes the blood's pH to be more alkalic. And when explored, the reason for respiratory alkalosis is a rise in the blood's pH, so you can kind of see the connection there. And therefore, the reason is that the lack of the enzyme in the urea cycle and its snowball effect it has. We know that when this enzyme does not happen, then the rest of the urea cycle cannot happen as well. Because if you don't have that enzyme, how could you continue that effect in the body? So we know that this is now the reason and why the little kid had this problem such early on. So now these are the articles that I used, and as you can see, I used 5 of them. And if you wanted to look more on this, you could look on them. They have more scientific terms, and if you're interested, and to just look up more on the topic. And I also used a PowerPoint, and it's the amino acid oxidation urea cycle PowerPoint from class. And that is my case study, and I hope the child gets better. But thank you so much for listening. Thank you.